next investigation is we're going to be kind of using this initial setup here to do another experiment with yeast to see if we can maybe manipulate some of these parts here to maximize the amount of energy that's being produced by the yeast. And as a result, as you can see, if we're producing a lot of energy, we're also going to be producing a lot of gas. So you're going to be researching some parts of this process here, whether it's complex carbs or it's the sugar, to see if we can kind of get the yeast to produce more gas for us. And I'm going to have you do some research today and tomorrow on the laptops. That's why we've got them around the station. And I've got some questions to help you kind of guide your research. So let me just go over the questions real quick and then I'll. So the first question is yeast alive in the packet? So when I gave you the packet yesterday, before you even added it to the plastic, is it alive? Explain why. What kind of information can you find out about the yeast in the packet? Question 2 is, I used warm tap water to make the starch solution for the yeast. Explain why. What kind of information can you find out about yeast and temperature? Is there some kind of a relationship? Question 3, when it says rising yeast, it says on here quick rise. Rises 50% faster. What does that mean? What can you find out about yeast and bread production or whatnot? And then the questions on the back are asking you about complex carbs, like starches. Are there different types? And simple carbs, like sugars. Are there different types? Any questions for you guys? And then you just make a couple predictions there. I'm going to let's have your communicator come up and grab handouts for your group, and you can get started with the laptops today.
Found something.
We found it!
There's one.
Okay, what'd you find? Okay. Active dry yeast is a form of tiny dehydrated granules. The yeast cells are alive but dormant because of lack of moisture.
Oh, okay. So, how is that different from, like, let's say, if you're looking at this piece of metal right here, isn't that kind of dry? There's no moisture in there, right? How is that different from this? If we added, like, water to the steel there, do you think it would come?
No, but that one's basically like it's sleeping. Yeah.
Oh, this is
not
more like it's
active.
sleeping. It's not actually like, it's never been something that's not alive. Okay, sounds good.
Is you're trying to gain some information about this process here. We've got kind of a rough draft of this process sketched out. We're pretty familiar with this extracellular digestion. We know quite a bit about that, but we don't know quite so much about the cellular respiration and these different parts that are involved in it. So as you're going through these research questions, I want you to keep in mind what kind of information are you getting about complex carbs or simple carbs or this type of gas that's being produced or where this energy is being used by the yeast. So you're going to be researching questions to help you understand this process a little better. Let's start off with maybe our complex carbs. What do you find out about complex carbs? Hey, Janie?
Examples of really complex carbs are like pasta and like potatoes and stuff like that.
Yeah, let's go ahead and add that to our journal here. So under complex carbs, let's write some of these examples down too. Potatoes, these are all things that we eat too. Potatoes, you said pasta. Dion?
Well, the gas is CO2.
The gas is CO2. Where do you see that on here?
The gas.
The gas here is CO2. Great. And what did you read about CO2?
It helps like give energy and make yeast rise.
You said
It helps yeast rise.
it helps yeast rise. Okay. What else do you know about the carbon dioxide that they have there? I think your group found out quite a bit. What else did you find out, Jasmine, about the carbon dioxide?
That's what it let out.
It's what?
That's what it let out.
That's what it lets out? Yeah, and I think you guys even read that story about how yeast would be embarrassed to know that they get a little bit gassy after doing this process. So we know this is, and this is kind of what Matt, you were talking about earlier about it being a waste product. So we've got this kind of being a waste product. Anything else you learned about this process here that we can add? Maybe even in some of these questions where we talked about is yeast alive, or what about the relationship between yeast and temperature? Yeah, Janie?
That he said on the website that so the yeast has a faster metabolism or can digest faster when it's higher temperatures, but when it gets too hot, they die. So
Great. So we can maybe add temperature or heat on here. Where can we add temperature or heat on here? It's important for something to happen. You're talking about digestion. Where do you think we might add heat then?
inside of the enzymes, you see that.
Kind of in this area here. So we've got maybe in this area here, heat helps that happen faster, you said? Yeah, Deanna?
Trying to add to that, we found that the heat makes them eat more of those simple carbs or sugars, and it causes them to release more CO2, and which makes it rise more.
Yeah, great. So we've got that too. When we're saying yeast is rising, well, you know what? Let's go back to this idea of heat too. I know this group came up with a really good discussion about heat when things get hotter. What do you notice about heat and the effect on other living things too?
They get more active.
They get more active? Like what's they?
Whatever it is, like the yeast, because you really won't be too happy if you're dunking cold water.
So where can is there another place that maybe we can add heat to, you think? So you're saying that heat is really important and it'll be more active. Active to do what? Let's ask that question.
Grow, reproduce, and eat more. It's probably big, put by energy.
Kind of near this area. So maybe if we have more heat here, we can have them do some of those things a little more.
Heat is needed to activate yeast so that they can make the chemical reaction happen.
Great, yeah, and so we've got that here. Heat helps it happen faster.
And so, because of that, the heated gas can be put into maybe in a bread recipe would help the bread rise, because it would form all these air pockets in the bread that would make it rise.
Oh, great, yeah, and if we are looking at the flask with my balloon, I use just kind of the hot water from the tap, and then I didn't keep them under heat for the rest of the day, and we saw them the next day, and they didn't get any bigger. But what do you think might happen if you just left this under, we left this in warm water or warm temperature for a couple of days? What do you think might happen? You can even look at kind of where heat affects this and think about what we end up with here.
I think.
Oh yeah, Avery, go ahead.
I think it might inflate a little bit because of the pressure needed to inflate the balloon. It might not inflate it that much.
Well, let's go back to the idea of what you're talking about with heat. What does heat drive things to do?
Well, it allows it gives it a more hospitable environment. It just makes life easier for the yeast, so it doesn't have to exert as much energy keeping itself warm.
Okay, so it doesn't need to keep itself warm. That's kind of interesting. Maybe we can add to that idea. Yeah, Maggie.
Well, if it were doing all those things faster, with more energy, we probably would run out of food a lot faster.
Oh, that's a good point too. So we might run out of food. If we run out of food, let's say if we run out of some of these simple sugars, what do you think the rest of this process would be affected? How would the rest of the process be affected? Anything? Yeah, Matt?
I was going to skip it.
Oh, so you want to take a guess? If we were starting to run out of food, what do you think might happen eventually to the rest of the process? Or these stages here?
They might slow down, and then a lot of those things wouldn't happen.
Like what? Can you be specific? What things wouldn't happen?
Like, they won't be able to eat anymore.
Okay. Yeah, we're running out of food. Any other impacts that running out of food has? Think about when you're eating food. You eat maybe some complex carbs or simple carbs. And why are you eating some of those things? Jasmine?
Well, it might run out of energy.
Yeah, so we rely on energy to do what? Audrey?
Help our body move.
Yeah, any other reasons too? Katie?
Like, well, when we were talking about how the food was, without food, like in human bodies, we can't live without food for like 3 weeks or water. So I think that would happen to the yeast that would start dying because they'd run out of food. Because if we were stranded somewhere and we didn't have anything to eat or drink, we'd probably die.
Yeah, so this process is kind of similar for us too. If we don't have some of these foods, and we won't be able to produce some of this energy as well. So you can think about that as well as with the yeast. It's kind of that same process as well. What I'm going to have you guys do, oh, you know what? Did anyone find out any temperatures that we can record here? Maybe some of the more ideal temperatures that yeast can grow in? Yeah, Micah?
They grow very quickly between 100 and 115.
100 and 115
And then,
degrees. Do you know if that's Fahrenheit or?
yeah.
Fahrenheit.
And then, but it's better for them to be in heat at 75 to 80 or 85 to 90.
Oh, so this temperature here would kill them, you're saying?
And that one, they grow too rapidly, and I can't remember what happens, but something bad happens to them. I don't really know what to do with.
Oh, okay. So here they can grow too rapidly.
Yeah, and then, so it's better to have them at like 85 to 90 degrees Fahrenheit.
85 to 90 is kind of our key.
And then they die around 120.
85 to 90, that's what you said, right?
Yeah.
Okay. And then, so anything above this, you would die?
Yeah, anything above 120 is that.
Right. Yeah, so those are important things to note too.